Welcome to another video, welcome to another homemade synth video. It's been a little while since the last video, I've been a bit busy, but I have got some tweaks and one new feature. I'll quickly go through those before going into the main part of the video, which is sound design. Okay, so first of all, I fixed up one of my long-standing bugbears, and that is that the CV in wasn't tracking properly. So it lost about a semitone to 1.5 semitones over the whole 5 octaves. That always annoyed me, and turns out I made a rookie mistake. I trusted that the 5-volt source was 5 volts. So analog to digital uses a source to work out what the value is. And it turned out instead of 5 it was 5.07 volts. Not really much of a change, I hear you say, but that was enough to make it between a semitone and 1.5 semitones out. So I put in a calibration so you can actually calibrate the whole range, and now you've now got pretty close to true tracking. Now there's every now and then there's a little bit out or something like that. You can still quantize, and the quantization is useful if you've got something like an unquantized sequencer coming in. Anyway, so that's the first thing. The second one was I've rearranged the buttons. Originally I just had them going up in any old voltage, and I just tuned all of the resistors to get things correct. But looking forward to creating a proper PCB, I really wanted it to be a proper step. So what I've done is all the buttons are now calibrated exactly 3 semitones apart. And you say, what, 3 semitones? Yeah, it's much easier. I temporarily put the buttons as the note coming in, and so that meant I could tune each button. So they're all equidistant, much more reliable now. And the third thing is that I have changed the button layout such that I was always messing around because it was long press to initialize, and if you put long press and you don't press it long enough, that's save. And so I kept on overwriting patches that I'd done. So now initialization is long press, that's long press additive, so initialize the additive, initialize the FM, change the FM ratio, and one new feature, pulse width modulation. Now I won't really go too much into that at the moment, other than I'll just show you now. There's still a few things I've got to work out. It's because of the very coarse nature of how much or how many bits I've got to play with. It can sound a little bit grating. Putting on things like reverb helps. So if I want to initialize, pulse width modulation. So you can press C on the oscilloscope. It goes up and down because the oscilloscope naturally gets rid of the DC component. So you can't see it, it's off screen, that's what all the wires are. I've got a Blue Marvin in the background. I've actually got a voice programmed on the Blue Marvin or patched, so I can play both together, but for the moment I won't use it. I'm just turning the reverb up, so that's pulse width modulation. You can change everything about it. We use the second envelope to actually control the pulse width. So if you have a repeating envelope, it's standard pulse width modulation. You can have it go down once, so it's sort of, rather than repeat, it just gives you a sort of a wah sound. You can keep it constant so that it's a single pulse width. But yeah, so it gives you pulse width. Alright, so long press, button 1. We're now back to our FM. So, designing sounds. Now, in fact, I've just made a decision. I don't want this video to go too many hours, so what we'll do is we'll take additive to start with. Now, I've done a few videos on how to create sounds and all that sort of stuff, but with all the new features like the built-in waveforms, the built-in envelopes, it actually makes additive really simple. That's great, but what happens if you're doing something slightly out of the usual? That's when people say, oh, additive's so hard, so difficult. Well, if you want to, you can treat the additive synth just like a subtractive synth. You do the same things, it's just you have far more control, and of course it's probably a little bit more difficult. But at least with the built-in, I'll call it filter equivalent for your envelopes, it makes things much simpler. So for example, here's our sine. We can hard code a sawtooth wave. So I'll just press oscillator 1, and I'll press volume, and so we're now getting our volume, which is according to the potentiometer, so we can hear it. But if I long press 1, now there's our sawtooth. And then if I want to put an envelope, so a standard attack, sustain, release. So I can do the same thing, oscillator 1, that's the attack button, and then what I'm going to do is hold the bottom left. Okay, and put in a bit of reverb. Okay. So I hear you say, well, they're just presets. That's not real additive. So yep, and I agree with you. So let's long press, reset the sound. Right. So what do you normally do in a subtractive synth? You choose your waveform. You know, that could be a triangle, a square, a sine, a sawtooth, a pulse. And then what you do is you choose your filter. Now, as well as just choosing the first waveform, a lot of times you can mix two together. Even in single oscillator synths, they normally have two waveforms or three that you can mix together. So, how would you do that? Okay, how would you do that on an additive synth? Well, this is where you really only need to know, well, let's just say two waveforms. That's your sawtooth and your square. Now the sawtooth is, it uses all harmonics, odds and evens. So for example, the harmonic, so that's the note you actually hear, is a level of 1, the second harmonic's a half, a third, quarter, a fifth, a sixth. Really, really simple. And that, see, we'll show you, and I've done it in another video, but I'll just quickly do it. So 1, 1. So 2, level, a half. 3, a third, and you can see the wave starting to get more sawtooth. So there's our sawtooth. Alright, so just remember that 1, a half, a third, a quarter, a fifth, a sixth. Okay, now reset it. Let's do the square. Now the square is exactly the same, except you get rid of all the even ones. So 2, 4 and 6 you don't do. So 1 is 1, 3 is 3, 5 is 5. There's an approximation of a square wave. Now with those two, you can now think about it and say, well, what if I would like square and sawtooth played together? Because that's sort of like a basic sound that a saxophone makes, because a saxophone has components of both square, in other words like a woodwind instrument, and a sawtooth, which is more like a brass instrument. So how would you do that? So we'll reset it. So what you do is you just add the harmonics. So if you say you've got one with 1, 3 and 5 and the other was 1, 2, 3, 4, 5, 6, if you add them together, so both of them have a 1, so that's 1 plus 1 is 2, there's only a half there, both of them have that one, so that's a third and a third is 2/3, etc, etc, etc. Now, of course, we've only got a maximum of 1, so what you have to do is actually halve. You know, you have to make sure that when you add 1 plus 1, the answer's 1, which of course doesn't work. So it's half plus a half. So let's have a half amplitude saw and a half amplitude square. Add them together. So it's a half plus a half is 1. So let's have 1 between you. That's only going to be the sawtooth wave. So the sawtooth wave's normally a half there, so it's a half the height, so it's a quarter. So 2 becomes a quarter. 3, you've got both the square and sawtooth, meaning that's a third. Normally it's a third each, so they're half height, so that's a sixth each, which means it goes back to a third. So if you see the pattern, we can also do 4. 4 should be a quarter, but it's a half the volume, so it's an eighth. We don't have an eighth here, so what we're going to have to do is use, so we'll give you, let's just say that's about an eighth. We can play with it later. 5 is a fifth, same way, because it's half a fifth plus half a fifth, which comes up to a whole fifth. And then sixth is actually going to be a 12th, which is actually going to be a tiny little bit. So there's our wave, which should be roughly a sawtooth plus a square. So if I play a note, you can see it comes down, then boom. Now of course we don't have enough harmonics to make it exactly right, but it's because that should be pretty much straight up and down the middle part, but it gives you the idea. And so now that's the basic sound. That's like mixing your two oscillators, same as in subtractive synth. It's just you had to do a little bit of addition yourself. Right, what we're going to do now is we'll just choose one of the bog standard filters that, or I say filter, envelope types that emulates a filter, which is that one. That's my favourite one for all the instruments. So we can say 1, attack, and hold it down. So now, so it's a sort of a beginnings, but so that's sort of a saxophone sound. And again, if you put, I'm not going to put much reverb, just a little bit, because you don't want it to be too muddy. That's too much even. Let's put it down even further. Now, saxophones normally have a bit of vibrato. They're famous for vibrato, but we don't want it on every note. We want it delayed. So let's use the delayed vibrato. So first of all, let's actually choose the depth, because the LFO is always running. So long press. So when I press the note, that's probably enough depth. It's too slow, but that's good enough. So what we're going to do is we will save that one. Now let's go to the LFO speed. So let's just say that's good enough. Okay, but we don't want that coming in straight away, so what we're going to do is go to the offset, or how long to wait. So all the way around, instantaneous on. So it now takes a little while to come on. I'll just turn him back on. So you can now so there you go. That's our sort of saxophony sound from first principles, but we treated it just like a subtractive synth. Now obviously there's a lot more you can do with additive. However, to get into it to start with, you really just have to think about it like a subtractive synth. Yes, I've got my cello sound, which I think I put in a previous video, and that cello sound was basically created by looking at a Fourier transform of a cello. Yep, okay. That's what normally happens with additive, but you don't have to. So hopefully I've shown you that you can build a sound up from scratch. So you could also do other silly things like, let's clear it. Again, all you need to do, so long as you remember the sawtooth and the square, you'll go well. So what we're going to do is, I want to have a square wave with a sine wave sub note. So what we're going to do is, we want a square wave around there, but we also want a sub down the bottom. Wow, how do you do that on Additive? Well, it actually turns out that's actually not too difficult. The only caveat is the main note is going to be shifted up an octave, because first harmonic, that's the note you'd normally hear, an octave above, a fifth, that's another octave, a third, well, so that's an octave between there and there, a third and a fifth. So what we can do is we can shift stuff. So if you remember, you have a sawtooth wave is the first, second, third, fourth, fifth, sixth, and it's 1, a half, a third, a fourth, a fifth, a sixth. If we started that as our main note, then an octave up from there, in other words the first harmonic, is going to be that note, and then the second is normally this, which is an octave and a fifth, which is this one. So you could make a rough sawtooth with just those three. So we're on the side. So what we'll do, first of all, we'll set this guy off. So no sound at all now. This is going to be our primary note. So we're going to give him a 1. Our second note is going to be this one, and he's going to be a half. And our third note will be this one, and we're going to give him a third. So if you have a look, there's our sawtooth, but it's now an octave above. So he's an octave above. That's all good. Now we can bring back our sub. So we can now listen. Anyway, so you can see, actually if I do a high enough note, you can see there's a sawtooth, but it's actually going up and down. That's because of the effect of the subharmonic. So, all good. That sounds more like an organ, because we've got no envelope attack decay. Again, you could do something fun like, let's put on a pluck. So that's holding this one. That's one of the predefined. So you've got your sawtooth, and then an octave below you've got a sub, a sine wave, and you can do any combinations of those. So let's go back. So I'll do just one more. Now what would happen if I wanted, say, a square wave with a square wave an octave above as well? So you can have, so let's just go our square wave. Now I can cheat, so square wave is the automatic waveform, the second one. So there's our square wave. Now I want an octave above. So a square wave is the first and third harmonics at 1 and a half. So if I start an octave above, because remember the first harmonic is 1 octave above, then you need 1 octave, that's the first harmonic. Second harmonic is an octave above that. Third harmonic is a fifth above that. So I just need that one at a half and that one at 1. So let's do 1, a half. And there is our adding 2 square waves together. So you can see the main square wave, and then those two cancel each other out. Yes, it's a little bit ripply, but that's just because I don't have a large number of harmonics. And it goes down. So So there's a waveform with two square waves, one an octave apart. And this time let's just go to the... So if you listen carefully, you can still hear that high octave. And if that was too noisy for you, for example, what you can do is, let's just halve it. So instead of that being one and that being a half, so that's now going to be a half, that's going to be a quarter. So the waveform now looks a bit different. It now looks like a stepped sawtooth. Okay, so we've now created two square wave oscillator. So as I say, you can treat it exactly the same as a subtractive. All you have to do is, okay, it's a bit of a pain, but you build up the oscillators, especially when you've only got 6. You just have to know sawtooth, which is every fundamental, 1 1/2, a third, a quarter, a fifth, a sixth, or a square, which is the odd ones, so 1, the third harmonic, and the fifth harmonic. And then you can move it up an octave, or you can add them together. You can do all these different things. You can change it. If you get to a point, like in the first one, where we didn't have a button, so we needed an eighth, then you use the potentiometer. So let's reset it back to... So for example, if I wanted... It's just easy to see those. So I can go all the way down till it's almost... Don't know if you can even hear that one. And all you do is, so if we had that as a sixth and we wanted number 2 as less than a sixth, we've got a reference. So there's a 12th. Okay, so that waveform is exactly the same as if it had done 1 1/2. It's just much softer. So that's really it. And then I haven't gone into the envelopes. Obviously I've got the pre-standard sort of patched envelope, and that makes things a lot easier, because 99 times out of 100 that's what you want to do. When you start doing weird and wonderful things, bell chimes and whatnot, you can change them. But basically you have an ADSR for every oscillator. Now if you want to emulate a filter coming in, the low frequency comes in first, then second, third, fourth. So in other words, the attack of the first one is the fastest, next fastest, next, 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 next. And then when you take your finger off, in other words, when you release, the high one goes off fastest, so it has the high of fastest release to the slowest release. So let's go back to, in fact, let's just do, there you go. So there's a sawtooth. Now if we go, in fact the easiest way to see it, a really slow pad. Now hopefully the microphone picks it up. You can hear that sort of wow sort of sound as the harmonics come in. So if I do, when I take my finger off, you'll see the top ones go, and everything goes in order. They don't all go down at the same level, okay? And you can see that it actually ends up as a sine wave. So that's just all the preset ones are. If I were to, for example, go back, so let's, when you initialize it, everything becomes like an organ, so it's instant on, instant off. So if I were to, again, sawtooth, unfortunately it's hard to see, but what we'll do is we'll set all the releases to very long, so you'll be able to see it all go down. So 1 release 6, 2 release 6, 3 release 6, 4 release 6. Now you see why I did all the presets, so you don't have to go through that. So when I press the button, or key, so see how they're all going down at the same time? So it looks like the wave's sort of flattening out because all the notes, all the harmonics go down at the same to the same time, so they all reach 0. So see how it looks like a sawtooth all the way to the very end. Whereas when you do the fake filter type thing, so we'll just go back to very long. So you can see even when it comes up, rounds out to a sine wave, so it comes up as a sine wave, rounded, and then straightens up. And you get that wow sound. So that is how you create filter effects. Now because you control every harmonic, you can create band pass, notch, high pass, low pass. You can have repeating, so that you can have one particular harmonic that comes in and out, it phases in and out, things like that. So that's where it starts getting a bit tricky. But at least for basic stuff, if you know roughly how the filter works, and especially with the little homemade one where I've got all these defaults, you can set your waveform and you can set your filter, and pretty much that's how a normal subtractive synth works. With a little tiny bit of maths in your head, you can add two waves together to create a complex wave. So, for example, here's my... So I haven't got it as a preset. So you can get your saxophone sound, which is actually a mix between saw and square. But the way you actually designed it was from a subtractive synth thought. So you're choosing your waveform. It's just a more complex way of choosing it, and then you're choosing your filter and VCA, because the envelopes actually encompass both filter and VCA, and you can emulate it. If everything goes up and down at the same time, that's a VCA. If everything goes up and down at different times, that's a filter, and you can mix the two together. Alright, so I didn't touch FM this time because I knew this would go too long if I did, but hopefully that has helped people. Most people will experience an additive synth through software. That's all good and well, it's still additive. If you're lucky enough to have a Kawaii or one of these additive synths, or even if you've looked online, had a look at the code and stuff for this one and built your own, well, I'd actually really like to hear your stories. But yeah, if you have an additive synth, they are really fun. Little tiny bit of maths in your head, and yes, it's not bad maths, then you can just add the things together yourself. I've got them for a whole heap of cheats so that you can choose weird and wonderful waveforms. Weird and wonderful waveforms, and you can choose your plug. So anyway, waffling on a bit now. So yeah, bottom line is, if you think about additive synthesis in the same way as subtractive, well, it makes it a lot simpler. You don't have to think as much. There's a lot more to do, a lot more buttons to twiddle, but at the end of the day you can get to a sound with an additive synth that you can do on a subtractive. In fact, I would say with enough harmonics you can get any sound that you can with a subtractive with an additive synth. And I know by definition that's correct, but that's, yeah, in reality, it just may take a little bit of time. Anyway, thanks for watching. I'll hopefully be up another video soon showing how to do the same thing with FM. Try to demystify FM synthesis, because once you get the hang of it, it's actually not that tricky. Alright, thanks for watching, see you in the next one.